Welcome, students. Today's lesson is called Solving Inequalities Involving Absolute Value. Now, I'm going to remind you, back when we had absolute value equations, anytime you see absolute value, there's two possible solutions. There's two scenarios. So the same thing's going to work with solving these inequalities. There's going to be two possible answers. And when you look at the first one, the absolute value of n plus 5 is greater than or equal to 3. The n plus 5, you're going to write two problems. N plus 5 greater than or equal to 3. Write it just like you see it, but drop your bars. That's one scenario. That's case one. That's one possibility. The other possibility is going to be that n plus 5 could be a negative 3. But when we're going to change that 3 to a negative, we're also going to flip our sign. So these are your two possibilities on an inequality absolute value problem. The n plus 5 could be a negative 3 or it could be a positive 3, and your sign will change when you rewrite it to a negative. Then you solve each one. So subtract your 5 away, and you'll have n is greater than or equal to negative 2. Then you work on this one. You'll subtract your 5 away again, and then you'll be left with n. N is less than or equal to negative 8. And once you have both answers, go down and graph it. So we're going to have greater than or equal to negative 2. So we're going to find negative 2. We're going to put a circle. The bar is under it, so we'll fill it in. And greater than means we're going to go that way. Then we're going to find negative 8. And we're going to put a circle around it and fill it in again because it's equal to. But it's less than, so we're going to go this way. So what you have is an or situation. It's either this or that could be your answers. And I'll give you a hint here, when you see a greater than or equal to in your problem, it typically is an or like this. It'll split apart. Now let's start. I have to get rid of part of this in the graphing to do another example. Let's do this next one. A minus 5, the absolute value of A minus 5 is less than 3. So we've got A minus 5 less than 3, drop our bars, or A minus 5 is greater than negative 3. We flip our sign and change the 3 to a negative. Then we solve. Add 5. A is less than 8. Add 5. Or A is greater than positive 2. We'll graph it. So we find 8. We put a circle. We're not going to fill it in this time because there's no equal to. And then we know it's less than, so we're going to be going this way. Then we have greater than 2. Here's our 2. We're not going to fill it in. Greater than is going to go this way. So that means here's your answer is right between 2 and 8. So A minus 5 is between 2 and 8 as your answer. So those are a union. Those are your difference. Less than becomes a union. Greater than is usually an or, where they're split apart. All right, let's go down to some more examples now. These are kind of problems that are going to be on your assignment. You're going to have two operations, but it works the same way. So we're going to have the absolute value of 4p plus 2 greater than or equal to 10. So we're going to rewrite it, drop in our bars. You're going to write the same thing again, 4p plus 2, but this time flip your sign and make it a negative 10. And then we're going to start solving. Add 2 first, and we'll get 4p is greater than or equal to 12. Divide by 4, you get p is greater than or equal to 3. Subtract 2, we'll get 4p less than or equal to negative 12. Divide by 4, and you'll get p is less than or equal to negative 3. And now, when we look up here, a greater than should mean these split apart. So we'll find our negative 3, fill it in, because it's equal to, and go less than. Find our positive 3, fill it in, and go greater than. And there's our answer. We've graphed it, solved it, and graphed both solutions. Okay, now we're going to clear this off and do one more. Pull over this problem. The absolute value of 2c minus 1 is less than or equal to 7. two scenarios. 2c minus 1 is less than or equal to 7, just like it says, or 2c minus 1 is greater than or equal to a negative 7. And we start solving. Add 1, we'll get 2c is less than or equal to 8. Add 1, and we would get 2c is greater than or equal to negative 6. We'll divide by 2. C is less than or equal to 4. Divide by 2. C is greater than or equal to negative 3. Being a less than problem, these are probably going to be a union. So we're going to go down here to the 4, and I'm going to fill it in. And I know it's going to go that way. And I might find my negative 3, fill it in, and it's greater than, so it's going to go this way. And sure enough, they connect. And there's your answer. All right, let's go to some more examples. You're going to have some where you have to express each statement using an inequality involving absolute value. These are pretty easy. All you have to do is write the statement down. Ramona's bowling score was within 6 points of her average score of 98. So this is what we're saying. If it's within 6, first of all, that's less than or equal to 6 points. So we know that's the range. It goes 6 points either way. So inside our bars, then, we're going to say her bowling score minus 98. It'll always be a subtract 98, less than or equal to 6, because its range is within 6. That's it. Let's do another one. The pH of a swimming pool must be within 0.3 of a pH of 7.5. So here's a starting point. Within 0.3 is less than or equal to 0.3. Then inside our bars, the pH of a swimming pool, so we could use the pH as our variable, less than 7.5. So minus 7.5 is within 0.3. And that's all you have to do on those is just write it, practice writing them. And now let's do another one right here. The cruise control of a car should keep the speed within 3 miles per hour of 55. So what would be your range? What's your minimum miles per hour? If it's within 3, okay, you can drive a minimum of 52 or a maximum of 58. That is within 3, either way. So the cruise control of a car, let's say the cruise, minus 55, that's in your absolute value bars, is less than or equal to your 3 miles per hour. When you solve this, you'd add 55, you'd get your 58. It has to be less than 58. Or if you had your negative 3, it'd become a positive 52, greater than 52. That's how that works. You're saying within 3. Here's your last section. You have to write an absolute value statement for the graphed solution set that you see. When we do this, if you'll remember back to when we wrote absolute value equations, it's always inside the bars x minus the midpoint, and then it would equal the distance. That was the formula. But these are inequalities, so you won't have an equal sign, but you still have a midpoint and the distance still go in the same spots. So you're going to start with x minus the midpoint, in this case is 0. That's in absolute value bars. But since it's a union, since they are within here, this is within negative 2 and 2, it's a less than or equal to because it's within, and then your distance is 2, so that goes there. And that's how you tell whether it's less than or equal to, as you look at it's within. We do this one. It's always x minus the midpoint this time is negative 1 right here. But if you put a negative 1 in here, it cancels and makes it a positive 1. So it's x plus 1. It's a union again from here to here, so it's less than or equal to, and then the distance, which is 4. And that's it. X plus 1 is less than or equal to 4. Let's do another one. It always starts with x minus. Our midpoint this time is your -1. Again, I put a -1 in here, it becomes +1. And this time it's an or. They go bigger than 1 or less than -3. So I've got to put a greater than or equal to, and then the distance is 1, 2. You still go from the midpoint between both dots and find your distance to each dot. This is saying it has to be at greater than 2. The distance from -1 is greater than 2 on both sides. That's what it's saying. Let's go to one more example like that one. Our midpoint this time, if you look at this one, it's not 5 because it's 1, 2, 3, 4. There's 4 spaces here and 5 spaces here. It's actually between 5 and 6, and it's 5.5. There's your midpoint. So it's going to be x minus 5.5 in absolute value. And again, it's an or, so it's saying the distance has to be greater than, and then if this is our midpoint, the distance is 1, 2, 3, 4.5. 4.5. Greater than or equal to 4.5. So go back and review this lesson as much as you need to, and make sure you understand all the rules with your absolute value, when it's less than, when it's greater than, and remember, always 2 answers. See you in class.